Hi everyone, we'll just give it a minute to let everyone join. There's over 50 people attending today, so it might just take a minute to let everyone in. Hello everyone, welcome to the second in our series of Marine Tech webinars. My name is Chelsea, I work for Plymouth City Council and I will be your host for the event. Just a reminder that during this webinar you will only hear myself and our presenters speak. We will not be able to see or hear any delegates. After the presentation we will be holding a Q&A session. Please use the Q&A chat bar to ask any questions throughout the presentation. If you see any questions that you would also be interested in hearing the answer to, give it a like and this will send it to the top of the pile. Just a reminder, this webinar is being recorded with the intention to be available to others on demand. Enjoy, and I will now hand you over to our Head of Smart Sound Plymouth, Dr. James Fishwick.
Good morning, everybody. Welcome to the second, as Chelsea said, of our webinars this week. It's a great pleasure to present that to you, and I do thank you all for taking the time to join us this morning. And I really hope that you find the next half an hour, 45 minutes a very productive time. So just in way of introduction, obviously, as Chelsea said, my name is James Fishwick. I work for Plymouth Marine Laboratory, and at Plymouth Marine Laboratory, I head up the technology and operational side of our Western Channel Observatory. I've worked for PML for 20 years now, since I graduated university. I started life there as a bio-optical oceanographer, which was working with satellite remote sensing and looking at the biology of the oceans using optical properties. I've always been involved in the Western Channel Observatory, and I have quite extensive experience now with sensors and platforms, sensor integration, and also many years of experience of working with SMEs and academia to develop new sensors and new technologies. More recently, PML are a key delivery partner of the Marine Business Technology Centre, and through that centre I now head up Smart Sound Plymouth. So I just want to spend the next half an hour or so going through a presentation with you to sort of highlight what Smart Sound's all about. I do apologise from the outset to those who have maybe seen a presentation on this before, but in ways of just making sure everybody's up to date, there will be a brief overview of Smart Sound. So the first few slides may be familiar to some, but bear with us because I do want to get on to the more sort of what's going on at the moment and what our future aspirations are. So hopefully we'll move forward now to our presentation, and I'm already panicking because I doubt I've clicked the option to play the sound within my presentation, but we'll see what happens when we get there. Thank you, Chelsea. Okay, so hopefully you can see my slides now on the screen. Smart Sound Plymouth it's a platform really for marine technology development. It's an area, an expanse of water which is dedicated to trials and development of all kinds of marine innovative technologies. You can see on my screen that the chart, and the blue section in the centre is really what depicts the area of Smart Sound. This is an area that we worked quite extensively with numerous stakeholders, authorities and water users, and also users of Smart Sound and people who do regular testing and development work to really select an area that was representative of all our requirements. So it does represent over 1,000 square kilometres of authorised and deconflicted water space. So authorisation is sought through the necessary authorities, and that's done in advance of all our missions. And then deconflicted, we work very closely with naval organisations and other water users. We have a group email address with some over 50 different participants who all use the waters off Plymouth and are keen to understand what missions we're conducting and where they will be, so that people can do their very best to avoid those areas. So clearly it's not an area that is solely for the use of smart sound. It is a water space that is used by other users. But unlike other sort of ports and harbours around the country, Plymouth is relatively quiet. We do have businesses that exist. We'd have the fishing industry, naval, port, etc., and various commercial operations coming in and out. But by and large, the waters off Plymouth are quite quiet and really do afford themselves to a great place to come and do development and missions and trials. And within this box, we have quite a diverse environment. We can obviously offer sheltered bays, shallow waters, right out to the extents of the smart sound, where we're in over 80 metres of water, which is great for facilitating subsurface trials of autonomous and subsurface platforms and sensor technologies. And also at those extents of the smart sound, we can, in particular times of the year, particularly obviously the winter time, see some very hostile water, some very hostile environments. So we can really put equipment through its paces, really expose it to the real world, what it would experience out at sea on various missions in the future. So we have buoy systems out on the smart sound, and our buoy on the furthest extent of the smart sound measured a 16-metre wave one year in a storm. So it kind of puts into context the kind of environment we can expose pieces of equipment to. The smart sound is heavily instrumented, and I will move on further into my presentation to detail the sort of instrumentation and the understanding we have of this water mass. And also, as part of that instrumentation, we have multiple assets that can be utilised to deliver a whole host and array of various trials and validations. And we like to think that we have a professional team. The team spans multiple organisations, which I'll move on to in a minute. And we all have vast experience within the sort of deploying pieces of equipment and autonomous systems. We do work to the MAS regulatory working groups code of practice, so all our paperwork, all our sort of authorization processes are in alignment with that. So our trials and validation missions are conducted in a very professional manner, very safe, and representing a very responsible industry. And really the key to smart sound is the accessibility. It's accessible in terms of cost through the Marine Business Technology Centre. It can be free of charge if you're an eligible SME or organisation. If you're not eligible, we work very closely with you to help you to deliver your trial and validation exercise within the budget that you can afford. It's accessible in the sense that it's close to shore. The furthest extent of the smart sound is just less than 20 nautical miles from Plymouth, so we can access equipment and facilities with very short notice. Very key to deploying prototype equipment is the accessibility of it, being able to get to it if there's a problem and to be able to tweak it and improve it and then redeploy it again. So it's accessible in that sense. And also, as I say, it's accessible in the sense that we will walk you through that trial and that mission. So organisations come into Smart Sound to utilise the facilities here aren't expected to come with a vast experience of deploying kit in the marine environment. We can help you take your technology, your prototype, marinise it, walk through the process of how we'll deploy it, and then we can help you to facilitate those missions and deploy and have the maximum validation you can for your asset. So I keep saying, what puts smart into smart sound? Apart from the technology and the smart platforms that we're trialing and developing, really what we're trying to say is what puts the smart into smart sound is the Western Channel Observatory, which is kind of the backbone of smart sound. It's a very significant international observatory. It has over 100 years of data collection. You can see on the chart on the bottom left of your screen a map of the smart sound. You'll see the words, or the station names rather, L4 and E1. These are very long-term stations. As I say, the data sets date back over 100 years. And the significance of this is, one, the longevity of the data sets, but two, the breadth and understanding of the variables we measure. We measure things right through from the benthic core studies through to the pelagic ecosystems and then into the atmospheric interactions as well. We have a very significant atmospheric observatory at Penley Point, and then other stations within Plymouth Sound. So we have buoy systems out when we take measurements hourly. We also have weekly research vessel visits. You can see the charts in the centre, our profiling sensor suite that we deploy from our research vessel. But the research vessel allows us to take water samples, and they come back to the laboratory, and then the whole host of variables are then measured using that water in industry standard methodologies that are proven and published methodologies. So they provide a very key ability to validate sensors that may be on trial on the various platforms, and also they contextualize the trials and work that's been undertaken. We've had instances in the past where organisations need to prove the weather or the sea state that they were trialing various pieces of equipment in, so we can provide that validation with key collaboration with the Met Office, and the Met Office do provide all the meteorological information on the Smart Sound. But as well as the in-water studies that we do, we're backed up with very significant world-leading remote sensing. So you can see the sort of the figure of the sort of the Southwest Peninsula with the remote sensing data around that. And it's a very key group. That group is now actively engaged with users of the Smart Sound, looking at what products they can provide to the Smart Sound users, what would be useful, the resolution that might be required, and really trying to step up that initiative to provide a very comprehensive package to Smart Sound. And also we have a world-leading ecosystem modelling group in Plymouth. The modelling of the natural environment in a digital format. The particular model that you can see in front of you now is an FVCOM model. It's an unstructured grid model. This is quite key to the delivery of the Smart Sound. This is a very sophisticated model. It allows you to have a varying resolution within that model. And you can see that it's called a collapsible grid. So round areas that may be of more interest, you can really increase that resolution up to a resolution of around 30 meters. And then areas which maybe aren't so interesting, you can expand out to about 8 kilometers. So it allows you to really zoom in on the key areas and understand the hydrodynamics, but also the sort of the more scientific parameters, the temperature, the water mass. Very, very sophisticated model. And these run on the core sort of computing capacity at PML, which is very significant. We have kind of three main computer cores, high-powered computing systems. The first one is a high throughput computing, and this gives over 1,000 cores and 5 terabytes of RAM with a 5 petabyte of network storage. The second high performance computing cluster we have offers 720 cores. And then the newest addition to PML is we're in the process of having an installation at the moment of a high-powered GPU cluster. That's a £1 million investment, and that's really aimed at advancing our artificial intelligence work and also our machine learning work. So PML has some very significant high-power computing systems which drive these ecosystem models, and later on in the presentation I'll come back to this sort of ecosystem model and why it's quite significant and the work's quite key to what we're trying to deliver here at PML. So the MPTC partnership, you will have heard last week from Rob Watson if you joined that webinar, is the collaboration between Plymouth City Council, Plymouth Marine Laboratory, the Marine Biological Association, the Universities of Plymouth and Exeter. And the combined collaboration that through the Marine Business Technology Centre and then the core delivery within the Smart Sound facilitates the sort of provision of the assets that you can see in front of you now. I've got various research vessels there of varying sizes and capabilities. We have an autonomous platform there, the USV Cetus, which I will briefly talk about in a slide in a couple of minutes' time. We have ROVs, the buoy systems. We have underway systems within our research vessels and profiling capabilities. So there's quite a strong capability of assets there that are available to organisations to utilise. I'll just run through a few of the sort of key ones within the Smart Sound. So the larger vessel on there is the Plymouth Quest. It's a very significant, capable vessel. It has quite significant lifting capability. It deploys all our own mooring systems for the buoys, and it also can bring back up to 10 tons of pristine seawater. So On the vessel, there's a dedicated hull intake, and the pipe that sits underneath the hull protrudes 1 metre below the hull. So therefore, we're not sucking in any of the bow wave that passes along the hull, any of the anti-fouling water or contaminated water on the hull. We penetrate through that, and we're sucking in pristine seawater. So we have the capability to bring back up to 10 tonnes of seawater. So that can be a useful resource for filling tanks and running experiments. And certainly for PML's point of view, we run a lot of our mesocosms and our seawater haul studies using that water. But key to the Plymouth Quest is, you can see the underway system. That sits in the fish hold rather. That's the instrumentation package that's on the bottom sort of right of your screen now. A very sophisticated package, measuring standard parameters like temperature, salinity, oxygen, chlorophyll, turbidity, absorbance in the water. But key to this is the ability to bolt on third-party equipment. So we can pretty much bolt anything on, build flow systems for equipment that doesn't have its own flow cells, and then pass the seawater through it. So this allows a user to be much more hands-on whilst you're testing and developing, and that water is circulated through the system as the vessel is underway. So it does provide a very good resource there for testing and development of equipment, and we have had quite a large uptake really on use of this equipment. I mentioned the USV Cetus. This is an asset that was procured through the Marine Business Technology Centre. And it's now in Plymouth. It's procured. Obviously, with the recent events and the current lockdowns, things are more difficult, but this is operated by the University of Plymouth, I should have said. But they are in the process now of enabling this vessel and enabling users to get on board with it. They're very close, if not already at the stage where people can now come in and work out how to integrate pieces of equipment onto the vessel if they're not yet ready to deploy the vessel. But we do hope that in the next few weeks, or at least in the month or so, this vessel will be out again on Smart Sound and being available for trials and testing. We do believe that this is really one of the only, particularly in the UK, facilities that's available that people can come along and use, an unmanned surface vessel for all kinds of development work. You can see there that it's got dry bays and wet bays, so you can get wet sensors, but you can also put dry electronics that were kept dry and away from the water. It has various underwater masts that protrude below the hull. It has a winch system that can allow you to deploy sensors down through the water column. And importantly, it does have a robotic operating system interface. So the platform comes already equipped with its own sort of autonomous operation software, which is very highly capable, but it does allow an interface connection to a robot operating system software, so you can trial and develop new marine autonomous algorithms. It's a very key piece of equipment. It has mission and engineering full support with it. And if you want to know more, the university will be doing a webinar on this on the 12th of August. But I mean, I'm conscious that's a couple of months away, so please feel free to get in touch through either Smart Sound or the MPTC, and the contact details will be at the end of this presentation, and we can put you in touch with the relevant guys to work forward with that. Also, there's moored data buoy systems that are available on the Smart Sound. We have 2 moored platforms, one at our coastal station L4 and one at our more offshore station E1, which is actually at the extent of the Smart Sound. They will all be on high-speed communication systems. They have a very comprehensive suite of sensors, novel anti-fouling technology within those buoys. And the key to this is that they have analog and digital port connectivity. So there's connectivity on these buoys. It's all about plug and play. It's all about getting people's equipment interfaced into these platforms and getting them out on the observatory, on the Smart Sound, being trialed and tested. And really key, I think, one of the nice feature to the buoy platforms is that they are powered through renewable energy, clearly solar panels on this one. And I'll just move on to a very key development. So this development is also funded through the Marine Business Technology Centre, and Plymouth Marine Laboratory will be delivering this. This is a replacement buoy platform for our L4, our coastal station. This is a very significant platform investment. It's to the tune of about £390,000 all in. This is now in build. It's almost complete. We're expecting delivery in the next couple of months. But it's very significant, and some key sort of features to this platform are an autonomous profiling capability. You'll see on the right-hand side of your screen the cross section of the buoy platform. Within the central moon pool structure, you kind of can maybe just make out there's quite a big sensor cage there, and that allows us flexibility to put on different pieces of equipment. So it's not a bespoke system that's controlled. It has a set amount of sensors, and those sensors are integrated in. That's all we can do. This system allows us to interface all kinds of sensors and platforms, one onto the buoy, but also within the profiling capability. Again, the both buoy platforms are collaborations with the Met Office. The Met Office provide the meteorological stations on these buoy platforms. We'll also be measuring light data from the sun. The wave sensors will be provided, so we'll have an understanding of the directional waves capability. And then the key parameters in the water are the seawater temperature, salinity. We measure sound velocity, which has been identified by some of our partners within Smart Sound as a key deliverable for their work when they're assessing underwater comms, etc., etc. So we now deliver sound velocity, and that's plotted live on the Western Channel Observatory website as that data is made available. Dissolved oxygen, chlorophyll A, colour dissolved organic material, turbidity, nutrients, and also pH levels are all going to be measured as fundamental parameters on this buoy. But key to this, we have embedded PC controllers, so interfacing your sensor onto a PC is quite straightforward for us. High-speed communication systems, so we provide a sort of a remote desktop type facility so that you can log into your particular sensor, see how it's doing, see how it's operating, make some changes to the software, etc., etc. So it really does afford a really high-end validation platform. And key to this as well is the power capability that we have. We have over 1,000 ampere hours of battery capacity, then 8 100-watt solar panels and 2 400-watt wind turbines. So power is well, potentially is always an issue, but for a buoy platform, this is very significantly powered and provides an awful lot of power for prototype and sensor validation. I've kept this slide in. We came very, very close to delivering an Autonaut onto the Smart Sound. Sadly, the funding was pulled rather surprisingly at the last minute, but we're working very hard to secure some further funding to deliver this. This is a significant capability that we want to add to Smart Sound. It offers a very complementary package to the USV Cetus. The difference is that the Autonaut provides much more longer endurance missions. The Autonaut can be quite comfortably operating out in the Smart Sound for weeks and months at a time. It will have high-speed comm systems, a large payload bay. This particular vessel that we will be aiming to procure will be a 5-meter Autonaut, so it does afford an awful lot of space in there for extra equipment to be added in and deployed within the missions. And again, as the USV Cetus, there will be full mission support for this vessel, and we hope that this will be procured and on operating within Smart Sound sort of within the months to come. So moving on, we talked about the partnership of Smart Sound being the sort of the MPTC partners, but a key part of Smart Sound is also the Future Autonomous at Sea Technologies cluster. That's a very significant cluster that is geographically based in Plymouth, but not necessarily confined to only organisations that reside in Plymouth. You can see in front of you, I'm not going to sort of start listing off all the logos you can see, but there's a very significant contribution there from very significant organisations. And you know, the FAST cluster comprises of educators. You can see on the screen, surface and subsurface platform manufacturers, advanced power systems, sensing developers and control system developers, and then even to the end users and the systems of systems integrators. So it's a very comprehensive group, very collaborative group, really key moving forward. We already have examples of proposals that have been collaboratively submitted, and really trying to step up the game from the sort of small individual proposals to much larger collaborations. And also these organisations don't only, you know, it's not only a forum for collaboration, but they also operate within Smart Sound. They provide extra facilities, and they also offer key advice and key direction and steer as to how we develop Smart Sound going forward to be a useful platform for industry and academia and basically, you know, innovative marine technology development. Part of what the FAST cluster was also hoping to deliver this year, in fact next week, was the Marine Tech Expo, which is a large expo here in Plymouth. It would have been in its 6th year this year, and a very large year was planned. There would have been conference going on, exhibition space, but key to this was on-water demonstrations, and that's really what the FAST cluster was hoping to deliver. Importantly, the expo has been postponed, it's not been cancelled, so we're hoping to deliver that in 2021. There is a website for that, so keep an eye on it to see when the dates get released as to when that will be. But we really have got a really key team of industry leading partners here that will be delivering some really high-end mission capability demonstrations. So you can see there the Smart Sound and the FAST cluster partners, with Ocean from Ireland had joined us, and Ecosilver Robotics had also joined us for those, and other partners. NOC, for example, will be here and demonstrating. So keep an eye out for that. That will be a great expo, great opportunity to come down to Plymouth, get out actually on the water in Smart Sound and see some real high-end, state-of-the-art mission delivery capabilities from these various craft. Moving quickly on, so we've talked about Plymouth, we've talked about Smart Sound, we've talked about the FAST cluster, but how does that fit into the regional and national significance? So we feed into Maritime UK Southwest, and I also chair the Autonomy and Geospatial Data Expert Group within Maritime UK Southwest. And that group really is about building the expertise across the region, the strengths across the region, and we're working closely with the Smart Sound Plymouth, the Portland test facility, and also the Falmouth Bay test site to really pool those test facilities, understand our strengths, how we're complementing each other, and collaborate to really deliver a real strong package across the region. And part of that is about raising the profile of the region in the national sense. So we've had many conversations with other national projects about how we can collaborate, how we can work together. And that doesn't necessarily only mean marine. We've talked to terrestrial and aerial projects, all looking in autonomy, etc., and technology and sensor development, and how we collaborate, how we can work together, and how we can pool our resources. And other key organisations you may have noticed on the FAST cluster, one of the logos is the UK Hydrographic Office, who are a key organisation who are involved in the Smart Sound and what's going on down here. And hopefully we're in conversations with others. We hope in the next few weeks that we'll start to sort of be able to discuss those and make some announcements of other organisations who are getting involved. And then key to that is about government and working into government to sort of build our profile and raise our game. We've had many detailed conversations with Department for Transport, and we hope to be making some significant announcements about that in the coming months also. And then internationally, the group have worked very closely with the Department for International Trade, and we have submitted a high potential opportunity which will facilitate some funding to allow us to build significant collateral to advertise the strengths of the cluster in the region, and then build that through the international contacts through the Department for International Trade. And there's a webinar on that on the 9th of September on the Maritime UK Southwest and the wider offer. Also, sort of some of the key deliverables of Smart Sound going forward. We've been very successful recently on winning some very significant amounts of funding to deliver an advanced communication platform. This has been identified for a year or so now as a sort of a key future progress, something we really need to get into place to really facilitate the trials and development on Smart Sound. And through this project, we'll be delivering in the first instance a fairly off-the-shelf advanced military-grade mesh network that'll be capable of interfacing in the static and mobile assets, as well as aerial platform integration. And that's about connectivity. It's about providing connectivity on the Smart Sound. First of all, we'll be connecting all the assets, the buoy platforms, the autonomous vessels, the terrestrial sensor platforms, and also some of the sensor platforms within the sound area. But also we'll have additional modems, additional aerials that can be facilitated for a whole range of platforms that will be able to provide to third parties to come and trial and demonstrate their equipment on the Smart Sound. And also the next stage of that funding has already been secured for is the 5G marine demonstrator. So within the port of Plymouth, we'll be installing a 5G network in there, looking to how we can move that 5G connectivity forward. And that is an initial phase. We're now in a much bigger collaboration looking at how we can bring that technology much more offshore and encompass the whole area of Smart Sound, and then really what can be achieved with the 5G, what the use cases are, and what kind of deliverables we can have. And one of those, and the sort of step game change for us, is about the digital twin. So we're working very hard now to develop a digital twin, which is about mirroring the real world in the virtual. So we're trying to build a digital twin of the Smart Sound that will have connectivity. We've already got sensor arrays around the sound area, around the port area, They range from webcams, AIS, so vessel tracking, meteorological stations, radar. We have various marine sensors and buoy platforms measuring out there, and they're all going to be connected together initially on the mesh network, but ultimately onto the 5G network for high-speed communication systems. The key, well, not the key, but one of the main sort of deliverables here is the integration of the ecosystem model. So remember at the start of my presentation, I showed you the FECOM model, and that's quite key here. That's about taking those pinpoint measurements and feeding in the hydrodynamics of the sound of the water column and the water masses, how things are moving around, and providing a sort of real world simulation of what's going on in the port. And kind of use cases, there are various use cases, but just to give you a few examples here, we're looking at smart ports, how we can use the 5G network, the digital twin, to bring work around learning how we can bring cargo and port. That's not necessarily obviously that big cargo ships are going to be coming in and out of Plymouth, but it's about using that digital twin, using that infrastructure to understand how that can happen, dealing with the individual technologies that would feed into those smart ports. Also, we are looking at sort of port control, asset management, remote bridge operations. A 5G network potentially could allow remote bridges for tugs, for example, but also within the digital twin, a digital twin of that vessel, so we understand the health and the restrictions around that vessel and how it's performing, where it is, and the tasks it's on with at that moment in time. And then moving on, one of the key deliverables, and there's a considerable work already underway in this, is about autonomy and how we can deal with autonomous within a port environment. Again, a lot of the control software, a lot of the algorithm development can be operated within a small vessel. It doesn't have to have a big cargo ship coming in through the port of Plymouth to sort of address those issues and understand how a vessel will operate. Having a digital twin will allow us to operate those vessels digitally, not in a real world situation, but in a digital environment. We can throw various scenarios at those vessels and understand how the algorithms, how that autonomous control software will respond in various ways. And that will go some way to the legislation and the credibility of these vessels and understanding how they could eventually operate into a port environment. And that's key to the network as well, and the sensor arrays that we will have around the port. So a vessel coming into shore, into port, we'll be able to log onto that network and then be able to utilize all that information to help it, to guide it and direct it as it comes through port. And then key to what this is and how this all gets underpinned is really ocean health and the environment itself and maintaining that environment, because it is key to delivering our future aspirations, not only around the smart ports, cargo, etc., but also around our leisure activities, our food resources, our oxygen that we breathe. The marine environment is very key to us. A digital twin, a 5G, a connected sensor, Internet of Things kind of environment helps us to really understand the environment, helps us to manage that environment properly, and really will set us apart on really how we manage our ports and our water quality. I'm conscious that I'm rapidly running out of time if I haven't already done so. I just wanted to quickly run through a few key examples of work we have been doing over the last sort of 3 or 4 years on smart sound. But it's key to point out this is the main partnership of the MPTC. There's other key partners who operate on the smart sound almost on a daily basis. Thales, MSubs, Marine AI, Sonodyne, Frugro, Autonomy, to name but a few. I've probably missed some out, but these guys are constantly operating out on the smart sound. So I'm not trying to say that what we're doing is the only thing. This is part of the jigsaw. So we do a lot of prototype sensor development for the National Oceanography Centre. They have quite a large team there developing new sensor technologies, and we help to validate those sensors out on the buoy systems particularly. We've done a bit of work with WIT Energy, looking at their energy harvesting device. We've had that deployed on our buoy system several times to help them validate the performance of that particular product. Loads of work with the Met Office, looking at various sensors, into comparisons between different sensing platforms for meteorological information, to give them an understanding of the best sensor technologies available to them and how they may be deployed on various assets. And to that end, we did a trial with Autonomy and utilising the Autonomy to deploy a standard Met Office package and understand how that would deliver those parameters against a more industry standard buoy system. So they could look for being able to deploy autonomous vessels into key interesting areas, but also if one of their key buoy network sensor platforms had gone down, they could operate an autonomous vessel in the meantime until they get that platform up and running again. A key sort of deliverable we did do recently, one of the more recent trials, was Ecosilver robotics. This was a really significant technology demonstration about having 10 gliders in the water at any one time, 3 on the surface operating a GPS communication network, and then 6 operating underwater, all communicating with each other at various depths to perform a very integrated and controlled high-speed survey of a 1 kilometre square grid. And this was a really great opportunity for Smart Sound to be able to deliver this trial. And I have a short video now, it's literally only a minute long, which is given by Ian Vincent, who's one of the directors at Ecosilver, and it's just detailing some of the things that we've been doing and how we help them out. And hopefully this is where I hope my sound's turned on.
Smart Sound has really helped us a lot. It's provided us with really ideal vessels in terms of having the Quest available, which is fantastic when we've got 10 AUVs on the deck, having the space to operate, and also a crew that's really well experienced and knows what it's doing has helped out enormously. Access to Explorer, the RIB that Smart Sound provides, again, it's been really handy to do kind of fast response, getting out to vehicles, picking them up out of the water and getting them deployed again. Also the coordination that's gone with it in terms of providing us with support, getting notices to mariners out, providing logistics. The Smart Sound Lab has been really useful for doing battery changes at the end of the day. It's just, yeah, been really good for a trial of this scale. Absolutely invaluable. Really helped us out a lot.
I've just got a few more slides to finish off. I'll quickly summarise this slide. This is a project that PML are leading. It's a national project, and it's really looking at how we can utilise the ecosystem modelling approach to direct autonomous surface and subsurface assets in a more autonomous mode. So it's about providing them with a mission criteria and allowing the ecosystem modelling to direct those missions, so that the ecosystem models will direct the assets more autonomously, more remotely. We had hoped, if we weren't in the current lockdown situation, that we would have 1 or 2 Slocum gliders in the water in Smart Sound at this time, proving this project and proving the capability of the ecosystem models. That's been delayed. The work on the ecosystem modelling and integration still certainly hasn't been delayed and is moving forward very significantly. And the platforms we hope to deploy as soon as we are able to do so. So this is a key project really moving forward in autonomy and how we can utilise modelling approaches in a scientific way in the early days to direct our missions. So it reduces the pilotage time of the glider operators. What's next for Smart Sound? Well, a state-of-the-art research and support vessel. Plans are already in process and fundraising is already underway to provide a much more significant vessel to Smart Sound, much more capability, certainly in the realms of lifting, access to the water, underwater communications from the vessel, and obviously the high-speed communication. So that's something, clearly vessels don't happen overnight, so we're hoping to deliver that in the sort of next few years to come, but that project is certainly well underway now. And then really we've delivered on the surface communication system, and we now really want to move forward with a subsurface positioning and communication system, and then in complementary to the surface vessels, we want to be able to provide subsurface platforms for trials and development of third-party equipment within the Smart Sound. Just to draw your attention to the fact we do have a website. There's a lot of information on the website, and our details are there as well to get in touch with us. But my sort of final slide, and in way of thank you very much for taking the time to listen to me today, and we will be going now into question and answers, although I've obviously, I think, significantly ate into that time, but they're the contact details. I have also asked Rob Watson to join the Q&A session now. He's the director of the Marine Business Technology Centre, so it may just be that some questions are more appropriate for Rob. But sorry, Chelsea, I've run over a little bit, but I'll hand back now to Chelsea in the Q&A session. Thank you.
That's all right, James. Yep, so the Q&A session is now open. We've had our first question come in already. If I want to add sensors to the buoy for 6 months, will this service be free via the MPTC programme? Rob may fill a little bit more information on this, but the MPTC is a European Regional Development funded project. So that means that we really have to offer that service free of charge. The funding within that project is really for SMEs within
the Devon area. So it is very regional specific. Having said that, is what I would strongly encourage you to do is contact me as soon as you want, and we will discuss that. And we'll give me an understanding of who you are, where you're located. It may be that you're free through the MPTC, and that would be great. Other than that, we'll work very closely with you to facilitate your validation and your trials. And I have to say, we've never failed yet. We've always managed to accommodate everybody who's come to us to help them out. So we're accessible, we're open. If we can't do it for free, we'll work out what we can do. And we have in the past sought joint funding. So we've maybe taken a bit of technology, a sensor development, and then with that partner, we've sought for a funding stream that we can then build in the trials and development within that funding stream. Or if it's of interest to PML and the data's of interest, we can work out other ways of doing it as well. So I just strongly encourage you to get in touch and we can have that discussion.
Thank you. If anyone else has got any more questions, please do post them in the live Q&A chat section. Right, got another one come through. So this one is from Chloe. Hi, just wanted to say thanks. That was really useful and interesting. Also introduce myself briefly. I'm the project and KA manager of University of Plymouth for the Cybership Lab. Listening to your presentation, it seems there may be scope for us to work together in the future, so please don't hesitate to contact me. So I will put that there so everyone has got Chloe's details.
Thank you, Chloe. I failed to mention it. Sorry, I've obviously talked a lot already. One of the things I was going to mention within the digital twin aspect is the work the university is doing on the cybership. We're very well aware of that. Obviously, the university is a key delivery partner within the MPTC, but it'd be great to meet you and chat and see how we can go forward. But I believe there's a lot of collaborations and future aspirations around cybersecurity within the smart sound, and particularly the digital twin and the 5G connectivity. So yeah, great, thank you.
Next question is from Reese. Are there any projects with collaborative airborne/seaborne vehicles, i.e. UAV/submarines? Apologies if I missed you saying this.
Yeah, no, the smart sound is key. We're working very hard to realise how we can operate aerial assets. There are examples of that happening already on smart sound, particularly Thales, for example, the Defence Prime, who have the UK Marine Autonomy Centre here in Plymouth. They have done several trials now with aerial platforms linking to surface and subsurface vessels. That's something we're really working hard to deliver. PML does now have an interest in aerial drones within the remote sensing group and various expertise within that group. And there is other expertise within the collaboration. So yeah, it's something we're key to deliver. I did mention in the mesh network section that the mesh network will have aerial drone modems as well, so we can connect in aerial assets as well as the surface and subsurface assets.
And the next question is actually on the mesh network. Can I add my device to the tech mesh network? Will I need a license?
So we're in the process. We've only just won the money. We're in the process of procuring that mesh network. We have already talked to several providers, so we have a good understanding of what that mesh network will look like. But the network as a whole, if it is required to be licensed, which it likely is, will be licensed as a whole. So individually, you shouldn't need a license. As I understand it, the modems will already be licensed for use on the smart sound. But that being said, that yes, we will have a whole array of modems, from ones that require power on powered vessels to down to 12 volts and aerial and surface asset connectivity. So we'll have a whole host of aerial availability, modem availability. And again, I just strongly urge you to get in touch and let's talk that through. If there's a particular application, if we know about it now, that may help through the procurement process to make sure we get what's useful. So thank you.
Next question is from Rob. Can you explain the campus project a little bit more, please?
Yes. So there is a website for campus as well, so please take a look at that. So PML are leading this. It's quite a national collaboration. There are other partners across the country, key partners, University of Essex, NOC and others. And that's about taking ecosystem modelling. So it's about the modelling of the marine environment. It's particularly obviously a marine application here, and particularly this project is delivering within the scientific world. So it's about modelling the ecosystem in a digital sense, understanding where key areas of interest would be, and then the model obviously allows a predictive nature. So we will have an understanding of where interesting features will develop. And then we'll be able to direct our assets to those interesting features to make sure that we're really capturing what's of interest to the marine science community. So the ecosystem models and the platforms will operate within the context of a defined mission. They'll have understanding of parameters that they're driving. But also another key part of that project is the integration of the live data stream. So we'll be taking data from the platforms, the remote sensing data that's available as well, and integrating that live into the models to give a much more accurate prediction. And then there's some more complicated modelling, which I don't pretend to understand, a probabilistic model, which is much more real time. It's about predicting things that are happening within minutes to an hour ahead of where you are right now. And that's much more about tracking interesting features. I hope that's enough. If not, please, again, don't hesitate to get in touch, and I can then put you in contact with the leads of that particular project, who will obviously be able to help you in much more detail than I can.
Okay, next question is from Russ. What is the typical lead time for booking resource or time on the vessels?
The vessels can be quite flexible. It kind of depends on the time of year. Obviously, going through the summer periods, the vessels are in much more demand, but I think we can usually facilitate people's work within a week or two, and we do have multiple vessels that we can pull in to facilitate this. And I didn't mention them in the presentation. I mentioned really the key MPTC partnerships, but there are other operators within the FAST cluster who also have vessels. So really, I think we can deliver vessel time in a very quick turnaround. I mean, the more capable vessels tend to have a bit more of a lead time, but I would have certainly said within a week or two we can facilitate most things.
Next question is from Faye. How long does the ERDA funding run for on the MPTC project, and will there be an opportunity to apply for an extension on this one?
So I asked you, Rob.
Do you want me to pick that one up, James?
I could answer it, but yeah, you might as well, because you are the director of the MPTC. You better than me.
Well, hopefully. Faye, just to answer your question, the original contract for the funding was to run to the end of this calendar year, so December 31st, 2020. Obviously, with the current situation, we have put in an application to extend that to August of 2021. But the future of the MPTC is very much to continue. Now, whether that is with ERDF funding or funding elsewhere, we feel that having an innovation service running alongside and fundamentally part of Smart Sound Plymouth is key going forwards. So the vision is to maintain the service, although it may change over time depending on where the funding actually comes from.
Okay, so next question is from Dan. He said, similarly, James, the new digital fabrication lab and immersive media suite in Levinsky are being mobilised by the University of Plymouth at the moment, so maybe potential there around the digital twinning.
Great, and thank you for that. And again, as I said earlier with the cyber ship, the university are key delivery partners in this. Kevin Forshaw is kind of, I suppose, your representative on this front, but please, yeah, get in touch. The more information we have and the bigger the understanding of what's available in Plymouth, the better the offer is and the more capable we can be collectively. So great, thank you very much.
Next question is, what role do you see the MPTC having in terms of attracting new innovative businesses to the area, and what challenges do you anticipate in releasing these aspirations?
Wow, okay. So I think that the MPTC is a part of a bigger jigsaw of what Plymouth offers. The MPTC offers a very specific innovation service around organisations that linked into Marine Enterprise Zone of Oceansgate and other assets, key shoreside assets in Turnchapel, and then the partnership of the Smart Sound. I think it's the collective offer of what Plymouth has to offer, not only in the assets, not only in the facilities that we have, but also the capability within Plymouth and the collaborative nature and the critical mass of organisations already operating in here. And we've seen in numerous examples now of organisations and businesses moving to the area to be part of that bigger collaboration. I mean, Rob's already said that the aspirations of the MPTC and the Innovation Centre are far greater than just the ERDF funding. We're very actively seeking more future funding streams and how we can deliver that. Chelsea, you know better than I do about Oceansgate offer with an innovation centre there and about facilities there for businesses to come and utilise, and the Smart Sound offer of being able to get out on the water and deliver high-end technology development and validation. I personally think that the key infrastructure, the key parts of the jigsaw are already in place, and I think we're already starting to see the fruits of that now with businesses, but also other key organisations moving down into Plymouth, setting up satellite offices in Plymouth to be part of the infrastructure and the collaborations here. I'm not sure whether that really answered your question there. Maybe not.
James, I can pick up on that a little bit. Absolutely, what you said covered a lot of it. But again, just reiterating one of the points that you made. For us, it's about having a proper offer for businesses that is comprehensive, and it covers all of the elements that Plymouth and the surrounding area can provide. There's a lot of work going on around that at the moment with complementary programs that are operating. But I think we need to get to a point where we're very, very clear as to what that overall offer is. And MPTC obviously forms part of that, but isn't the whole. So that work is going on. Clearly, we're in discussions, as James said, with central governments and also national and international organisations around this, and the visibility of what we're doing is increasing all the time, and it's snowballing. So this comes back to the point that we want to maintain what we're doing and expand on it in the future.
Okay, so that nicely brings our Q&A session to a close. Thank you everyone for attending today. If you have any further questions on anything we've gone through today, please contact James and Rob. I will also just send everyone a follow-up email with all the website links from today, so you can have a look at everything in a bit more detail in your own time. Rob and James, anything further?
Just to thank everybody for their time today. It's really appreciated, and thanks for the opportunity to share the Smart Sound and what we're doing. And again, just to reiterate, please get in touch. We've had some great questions, but make contact with us. Let's further those discussions, and we really want to help you guys to develop the technologies you are doing. So yeah, great, thank you.
Same from me, Chelsea. Thanks everyone for your time, and yes, we're here to help. So please get in contact.
Okay, that's great. I will bring that to a close. Thank you everyone, and goodbye.